So we're going to continue on with our somewhat extensive example involving an inheritance hierarchy, where the classes involved potentially have both parents and children. The only class that doesn't have a parent, of course, is the top level class object. So whether you want to or not, any class that you write in Java, if nothing else, it's going to have object as a parent. Okay, so even if you don't explicitly use the extends keyword to specify you want to be a child of the object class, it's automatically done for you. Okay, so we've talked about some things like the trickiness with making sure that you call your parent constructor first using the super keyword. We've talked about the protective visibility modifier. In fact, I think we'd gotten as far as we were inside this hourly class all the way down here at the bottom. So let me remind you about it. Oh, there it is. It's already selected. Okay, so it extends employee, but it's part of a fairly lengthy inheritance hierarchy. It's going to potentially inherit stuff from staff member and from object, not necessarily just the parent. It could, in principle, inherit something all the way from a parent, a grandparent, a great-grandparent, as long as any of the intervening classes don't override that method. Okay? So hourly actually has a lot of complexity with respect to the stuff that it's inheriting from its parent class employee. It had a new instance variable that we're keeping track of a little bit differently. We've got some new methods that we haven't seen before because we have to keep track of and reset the number of hours worked, because their pay rate is not a salary like it is for employee. Their pay rate is their hourly pay. So we have to also keep track of the number of hours they've worked since the last paycheck. Okay, so we have to have methods for that. So there's some new stuff that appears in the hourly class that really hasn't been necessary to this point. Okay, but nevertheless, we still have to make sure that all the values in our parent class get set up correctly. So we've got to pass all those things to the parent class using super, parent constructor. And of course, we want to set our hours worked to be 0 initially. Okay, and as they work some hours, we're going to call this method to increment the number of hours they've worked. The pay method is going to be based on the variable that's stored in the employee class as the pay rate. Okay, but for an hourly employee, the way that's set, the value coming into the constructor for hourly, it's going to be an hourly rate. Okay, but we store it in the parent's variable pay rate. So that's a little bit of a confusing thing. We know that we need to pass an hourly rate because we're using the hourly constructor, and we've got to pass a value in there. It makes sense that that's going to be the hourly rate for the hourly class. Okay? So we've got some work to do when it comes time to pay, because the thing stored in the parent class is not the actual salary. We have got to compute it based on hours worked. And so get the value out of the parent class, call the pay method, multiply that times hours worked, and reset hours worked for the next period, for the next payment period. Okay? And finally return their total pay that the hourly employee got. Executives work very similarly to what we've got here in hourly, only their new variable is a bonus. So they've got to have the ability to get the bonus out, reset it after the pay period, and award the bonus if it's been earned over the course of the last pay period, last month or whatever. Okay? And so the variables passed to executives parent, which is employee again. Okay? It's going to be the same 4 stuff that we dealt with in the hourly class, except for this rate is again going to be a salary. Okay, we know it's a salary because we're passing a number to the executive constructor. But it just sends it on up to its parent to be stored in the employee class, even though it's not a regular salary. It's the executive salary, which must be adjusted to award a bonus for that pay period if it's been earned. Okay, so if they did get awarded a bonus, I'm going to need to add that on to their pay. Okay, so all that discussion The main thing to take away from that is we've made sure that these classes way down here near the bottom of the hierarchy, hourly and executive, have new methods. That's going to have some important consequences. Okay? They've got new methods to set and reset the hours worked for hourly and to manage the bonuses for the executive. Okay? So they have special things that have to happen that none of the other stuff in this inheritance hierarchy necessarily needs to deal with. The employee, their pay rate's their pay rate. Just return it. The hourly, their pay rate's 0. Just return it. So no real adjustments had to be made to the pay for the volunteer employee. Just hourly and executive. Okay. So going back to our 3 concepts now, we've been working on inheritance, and now we're going to see how inheritance allows us to learn about polymorphism. Okay? Because what I want to be able to do here, one of the power that we have with respect to an object-oriented programming language, is I have the ability to let my objects take different forms, especially if they're part of an inheritance hierarchy. Okay? So the keyword that we use when we're describing inheritance is the is-a relationship. In fact, we've already covered there's is-a versus has-a. Those are the 2 competing schemes for design when you're trying to write some software. One of the decisions you have to make is, do I want to use is-a or do I want to use has-a? Is-a is what we're doing right now. Has-a is what we did before with object composition. It is, as we will see in later classes, what you should consider first. So although we're doing inheritance second here in this list, it's the least important of the 3 major concepts. Encapsulation is more important, and that's where your has-a relationship comes in. Okay? Polymorphism is important as well, but not in the context that we're going to learn about it for the first time. Okay? Just so happens this is the first time that we can apply polymorphism now that we have an inheritance hierarchy. We're going to use it again without inheritance, and it's going to be a lot more useful to us. But let's learn about it. So polymorphism means different forms. So what I want to do in my driver class is I want to declare an array of type staff member, and I want to populate it with volunteers, employees, hourlies, and executives. Okay? So this is the idea. Brackets. I'll call it staff list. And let's just say we've got 10, we've got room for 10. Okay? So this is how we use polymorphism. I create an array, and I gave that array a type staff member. The nice thing about polymorphism is I'm not restricted to just creating staff members and placing them in this array. I can use anything at the staff member level or below. I guess it was on a different slide. I can put any of these things in the staff member array because a volunteer is a staff member, an employee is a staff member, an hourly is an employee, which is a staff member. The only thing on this list that I can't put in that array is object. Okay? Because the relationship is the opposite. However, if I declared and created an array of type object, I can put anything in that because of polymorphism. Everything is related to, at some point or another, to the object class. So if I create an array of type object, I can put anything in that array. Okay? The problem with that, as I've alluded to in previous classes, is now we can mix together all kinds of very unrelated types of objects. I mean, I could say, okay, we've got rational numbers. Those are objects. Okay? We could write a tire class. That's an object. The problem I can get into is now I can put tires in there. I can put rational numbers in there. I can put objects in there. Employees, executives. Okay? So object is usually too general to be useful. It gives you too much flexibility, and you can mix all kinds of unrelated stuff together. So we're going to stick with the staff member array, and we want to place all those people in there. Okay? So here's what it might look like in memory. I might have an employee in that first slot. I might create a new employee. I'll just show you an example of a few of them. I might create a new volunteer and put it at index 3. I might create a new hourly and put it at index 9. That's all fine with this array. Okay? And that's the basic idea of polymorphism, is you can treat it as, you can treat an object not necessarily just of its own type, but you can treat it as a type of anything above it in the inheritance hierarchy. Okay? So hourlies, whoops, once again, hourlies can be treated as employees, hourlies can be treated as staff members, hourlies can be treated as objects. Okay? Hourlies cannot be treated as volunteers. That's not that's not a direct relationship between hourly and its ancestry. It's off on another branch. Okay? But anything along its particular path from root to leaf, I can treat it as that particular type. Okay? Why is that useful? That's useful because what I want to do with my staff member array is, I'm super lazy. I really just want to go through all the indices of the array, call their pay methods, add, so everybody's getting paid, add up all the amounts that I paid to all my staff members, and have a running total for what my payroll was for that pay period. Okay? I don't want to have to worry about whether they're hourlies or executives or employees or volunteers. I just want to zip through there using a for each loop. What do I call it? Staff list, I think. I can use a for each loop to loop over each element in that array. And the type of the array is staff member, so I better make the type of each individual element be staff member. And I've got a variable called payroll that I want to sum up the payroll for that pay period. And I just want to say payroll plus equals staff dot pay. Okay? Nothing could be simpler. There are a few caveats. This isn't the perfect solution because remember we talked about using a for each loop with an array. It's only going to work correctly and not give me a null pointer exception if the array actually has elements it's being completely used. There's no unused indices in there. Okay? If that might be the case and you're not certain that that's the case for your array, you need to use an array list. Then the for each statement will work correctly. The array list keeps track of which sections have stuff in them and which sections don't. Okay? But here, let's assume I filled up the array. So I can make use of my for each statement. The next thing is, what methods am I allowed to call on those things? Well, here's why this statement will work. It will work because staff member has defined a pay method. So I know that everything from that level below will have a pay method, because if they don't have one, they're going to have the inherited one. It's public. So the method will be inherited. They may override it, but still it's going to have the exact same method signature. So either they'll override it or they won't. Either way, there's going to be a pay method there. Now we overrode it. Volunteer overrode it to return 0. Employee overrode it to return whatever pay rate was being stored in there. Okay? So all the children of staff member overrode the parent method. but nevertheless, the method itself is guaranteed to be there and have something in it. Okay? If I didn't write a new one here, I would simply be using the inherited one. So one way or another, I'm guaranteed that there will be a pay method. So that's why that statement will work. Okay? Here's the cool thing about polymorphism. As I just said, the child classes don't keep the parents' pay method. They change it. So even though I'm not keeping track of where the hourlies are, they're all mixed together, polymorphism will call the correct method. Okay? So when I'm at index, I'm at index 0 of my array where I placed an employee. We're going to call employee's pay method. When I get to index 3, I created a volunteer. We're automatically going to call volunteer's pay method. Okay, so that's the idea of polymorphism. I can just zip through there without knowing which one was which class, which one of the children it actually was, and I'm confident that the correct pay method that I overrode in all those children classes will be called. Okay? So in fact, I expect when I'm done here, when I do system out println payroll, I'll get whatever I'm supposed to get, which I think is 20,000 and something. Let's find out. $20,059.05. That was my payroll for the particular example that I set up inside my driver class. Now, if this was all there was to it, I would get the wrong answer. Compiler would be happy. It'd go through there and call the correct pay methods. Everything would be honky-dory. But I'm going to have a problem with a couple of the people. In particular, my issue is a couple of types of people. There could have been more than two. What we did down here was intended to create this problem so we can illustrate something important. Okay? Remember, for hourly to work correctly, I had to set the hours. For executive to work correctly, I had to add in their bonus if they earned one. Okay? Did I have an add hours method in staff member? Can't remember that long ago. No, there's no add hours method. That doesn't get introduced until we get all the way down to hourly. Likewise, there's no award bonus. It's not necessary at the staff member level. It only matters when we're trying to define the executive type of staff member. Then we needed those special methods. So those aren't going to work the same way. The stuff that works automatically is the stuff that's been defined at the staff member level. We don't have add hours, we don't have award bonus, we've got a problem. Okay? So here's how we'll deal with that problem. All right, so I actually need to move this down. Now, I do have to worry about what the types are. I can't rely on this automatic thing because add hours and award bonus are not defined in staff member. So it's not going to automatically call the correct thing for me. If I try to call add hours, I'm going to get a compile error. However, there's a way that we can check to see what type each one actually is. When we come across someone who's an hourly, we'd like to know that so we can do their add hours method. When we come across someone who's an executive, we'd like to know that so we can call the award bonus method. Okay? So there's a operator in Java called instance of. Okay? So as I'm working my way through this array of staff members, I'm going to check to see if it happens to be an hourly. Okay? If it is an hourly, Then I want to call the add hours method, whatever their hours are. We can make up something, let's say 40. Okay? Okay, so there's a couple of ways that I can do this. I'm going to show you, I guess, the clean way first, and then the sloppy way second. Okay? So the clean way is I've got to now change I need a new variable. I need a new variable that's no longer type staff member, but type hourly. Okay? So hopefully you're not unfamiliar with this syntax. I've done a cast there. And so eventually, so some of you are discovering the fun of null pointer exceptions. Okay? There's another super annoying one called class cast exception. Okay? Which will eventually start to haunt you if it hasn't already. And that's it. If I had actually done this statement, I try to cast to an hourly, but it was a volunteer, that's a class cast exception. Yes?
Around hourly, are those supposed to be brackets or parentheses?
Those are parentheses.
Thank you.
Okay? This is all done in code, so I am going to show you the completed version in just a minute. And it's obviously going to look a lot neater than my chicken scratch here. Okay? So class cast exception occurs when I try to do a cast, but it wasn't the right type. Okay? So of course that's why we had to check first. We can't just willy-nilly start casting stuff to hourly. We're going to crash. So we check to make sure, is it going to be okay if I try to do this cast? And that's what instance of does. By the way, it's all one lowercase word. Okay? Not that I care if you do it as 2 words on the test. I'm probably not going to care. So after we cast, now we've opened up. We've got a variable of type hourly. Now we can call all the methods declared in hourly or hourly's children classes, which it doesn't have any in our design. Okay? So everything defined now in hourly is available to us. So we can do an h.addHours 40 or whatever. Okay? Will that affect the original object that was in the array when I do that? Yes, no, or maybe? Maybe? As far as you know? It will, and here's why. We created something called an alias, which I've mentioned a few times. So suppose our object is down here, our hourly object. The array points to it. I created a new pointer that points to it as well. Okay? The different types. This pointer up here is type staff member. This pointer down here is type hourly. But they point to the same object. Okay? So you'll probably get asked about aliases on the exam. 2 pointers that contain the same memory address are aliases. Whatever I do, whatever methods I call on one to change stuff, the other one's going to be affected because it points to the same thing. Okay, so hourly is not immutable. We can change its contents without creating a new hourly. But that kind of makes sense for that particular type of object. Okay, you can't make everything immutable. Sometimes you have to be able to change stuff. Okay? So the sloppy version of that, so we rewrite this. So I could say staff member dot add hours. Actually, what did I call it? I called it staff. And now I lost it. Staff. Staff dot add hours 40. Okay, that's a terrible hours. I guess I'm the only one that does a lot of writing in here because it seems like the calibration is so far off that no one could someone would have to complain by now. Okay, maybe everyone else just used PowerPoint slides, I don't know. So staff.addHours 40 That's not going to work. I'm going to get a compile error. Okay, it's going to say staff is type staff member, doesn't have an add hours method, can't do it. Okay, but I can be tricksy and do this cast all at once like that. So let me show that a little bit more detail. I can say temporarily cast this without me wasting time declaring a new variable, temporarily cast staff to hourly, and then I can call the add hours method. Okay? So of the two, so although I've created more lines of code here, doing that in the two-step version is probably more readable. So readable code, usually in many cases, it's the shorter code. Fewer lines means easier to understand, but not always. Sometimes adding a few extra lines, which of course aren't going to make it when the interpreter runs, it's going to optimize out a bunch of this stuff. It's not going to matter in terms of performance, but in terms of looking at the code and understanding it, sometimes more is better. Okay, although frequently short stuff is also good. Fewer is better. It just depends. Okay, we've seen all that. I'm going to have to do something similar for executive. So now let's look at staff driver and see the finished version. And I've probably already... Okay, so I called my staff list was my array. I called each individual one employee. I called all their payroll methods. But I had to set it up, so I had to make sure that at some point previous to this that I went through and adjusted the hourlies and the executives to have their appropriate stuff. So here's main. I call setup first. What does setup do? It just creates a bunch of executives, employees, and hourlies and volunteers and puts them in the array. Okay? Then I go through and do our trick with the short version where I cram everything in one line so that I can adjust the hours of the hourlies, which I know where they are. Okay? Index 3 and 5 has hourlies. Index 0 has an executive who needs to call their award bonus method. So I manually do this thing. I'm not taking advantage of polymorphism because I can't. Okay? To use polymorphism, the method that I want to call has to be in the parent. It has to be somewhere in the parent. So that everyone from that point on is guaranteed to have that method. And then I call the payday method, and that's where I simply go use a for each loop on the array, call the pay method on all of them, and I get my payroll of $20,059.05. Okay? There's some other stuff commented out in here. That's for much later. We're going to come back to this example and do a whole bunch more fun stuff. But for right now, don't worry about it. Okay, there's a lot we have to learn between now and then. All right. So that's polymorphism. Now, let's make stuff more confusing. Notice there's one thing missing from the stuff I decided to put in there. I put executives, I put employees, I put hourlies and volunteers. I don't have a staff member. Okay? In fact, it makes I don't really need I'm not going to need a staff member because remember what we did? We just put in some silly arbitrary pay value because I kind of knew ahead of time that the staff member does not represent a complete employee. What I created staff member for is so that, where'd that thing go? So that the stuff that volunteer and employee have in common is not duplicated. Okay, without the staff member class in here, if I have object with a child class volunteer and a child class employee, in other words, bypassing staff member, then I've got to have your address, your name, and your phone, and whatever else in both the volunteer class and the employee class. Okay? Well, a lot of times you'll have two classes and you'll realize there's a lot of code duplication in these two classes. So you can take the stuff that's common to both of them, move it into a parent class, and then inheritance will automatically make that code available to both the children. So then if you find a bug somewhere in that code, you don't have to change it twice anymore. You change it once. That's the whole idea of getting rid of code duplication. Debugging is much easier. Okay? As well as the fact that now it's going to improve readability. We've got less code because we removed all the code duplication. However, frequently that process of realizing I've got code duplication, let's create a parent class. That has a name, by the way. That's called inheritance by generalization. Okay? So an example of that is we realize that volunteer and employee have a bunch of the same stuff in them. We create a parent class with that stuff, and we let the children inherit it. Okay? That means frequently the result of that is going to be the following thing. This parent class that I created through generalization does not represent a complete staff member on its own, or complete whatever class of stuff we're building on its own, because it doesn't have a meaningful pay method. Okay? We just filled that in because I wanted the children, I wanted volunteer to have a pay method, I wanted employee to have a pay method. So I have to define it in the parent class so that I can use polymorphism and do what we saw here in the code. Okay? I wanted to do this. I'm going to do have everything on one line. Okay? So how do we fix that? So we still have one issue with staff member, and that's that silly pay method that doesn't really mean anything. Well, here's how we fix it. We're going to use an abstract class now. So we're going to add a keyword abstract here. Okay? What that's going to do is I'm no longer going to be able to use the new keyword with staff member on its own. Okay, if I try to use the new keyword on staff member, I'm going to get a compile error. I can create a new volunteer, I can create a new employee, those are not abstract classes, staff member is. And now I can do something that makes more sense. I can get rid of this silly pay method that doesn't do anything useful, but still have the pay method defined in the parent class so that my polymorphism still works. Okay? I define the pay method. The child are guaranteed they have to write a pay method. So I know that they're going to have a pay method. Volunteer returns 0, employee returns their salary. So my polymorphism stuff will still work. Okay? But now I've made sure, so I've got a couple things in here. In fact, this would not make sense. I can't make a regular class with an abstract method in it. What I'm basically saying when I create an abstract method is, I really don't want to implement this here. Okay? I want to force my child classes to implement it. I don't want to implement it. Well, it's impossible to create, using the new keyword, a class that has incomplete methods in it. So if I can't use new to create a staff member, it needs to be abstract. So you really can't have one with the other. If you have an abstract method, you must have, that class must be made abstract. Okay? So that's okay. The only thing that I lost here is the ability to use the new keyword with staff member. But I haven't lost anything in that case because I wasn't creating any staff members anyway. Okay? Because that parent class didn't do anything meaningful. Now, I just see something that if some of you are probably thinking about this already because we're looking at it. Is that going to affect anything in this statement here? I made staff member be abstract. Is that going to break my program? Is it going to compile still with the fact that I'm using it in an array? You have a 50-50 chance, yes or no. Will it break my code?
You can go with yes this time.
And you go with yes this time.
I said no last time.
Okay, the answer is no. But at least you're brave enough to give a response. Okay? Here's why. I didn't create a staff member. I created an array. Okay? I said the array can hold stuff of type staff member, but I never actually created a staff member on its own, just in an array that's going to be filled with them. And I can fill it with stuff that's part of the staff member hierarchy. That's just fine, as long as I don't create a staff member on its own. I can create an array that's supposed to hold that abstract type, but I can't create that object on its own. Okay? So this, in fact, will still work even though we went in there and made staff member be abstract. The alternative to that. So here, what I'm saying is staff member must have a child class. Okay? If I create a child class for staff member, it must have a pay method. So what you're implying when you have an abstract class is you're saying, for this code that I've placed in here to have any meaning whatsoever, it better have a child class, or I just can delete it. I don't need it. If it has no child classes, just get rid of it. Okay? But we do have child classes. So I'm saying using abstract class means I expect there's going to be child classes. What if I wanted to create a class that I wanted to prevent from having any child classes? So let's go down to the bottom of our hierarchy here, to hourly and executive, and let's say that we know, or I have in mind when I designed this hierarchy, that hourly and executive, and volunteer for that matter, should not ever have any child classes. In fact, let's do volunteer first. Probably doesn't make sense for volunteer to have a child class. Well, I can make sure that no one ever tries to create a child class for volunteer using the final keyword, which I mentioned right here in the comment. Okay? So now if somebody tries to extend volunteer, they'll get a compile error. So, the question I'm going to put on the test is this. What can you tell me about the following class definition? Okay? Public abstract final class, my class.
We'll have no children.
Okay? It will have no children, but that doesn't make any sense to define the class. If I make it abstract, it has to have children. So using those two keywords together makes no sense. In one, you're saying, I expect this class is going to have children, and the other one's saying, I'm not going to allow it to have children.
So it won't even work.
So it will be a compile error. So the answer to the question on the exam, explain that, but this is not allowed. You cannot use both of those keywords together.
Is there any situation where you would or could?
No.
What's the word that begins with an F?
Final,
Final. Okay.
as in final countdown. Okay? Okay. Probably don't have enough time to do the next big topic, so let's change gears and do something a smaller topic. And that is complete our discussion. Oh, any questions about that? I mean, that's a lot. What we did just now is a lot of stuff. Okay? In particular with the casting. So there's some rules for casting, when you have to cast and when you don't. And that's all related to polymorphism. Sometimes you treat all the types, you don't care what the type is and everything works. Sometimes you have to do a cast in order to make it work the way you want it to. Okay, so the rule is to look at the type, so polymorphism rules. Okay, next time I'm going to pick up on this and give you the full-blown version of this rule. There's a lot of details in here that the simple rules that I'm going to talk about now will work 90% of the time.
What happens if you use the keyword final on an instance variable? in a class that, like,
Okay, so what you're saying, if you use final on a variable, so the final we're talking about is the class definition. If you put it in front of a variable declaration, you're saying this pointer can never have its address changed once it's set once. Okay? In fact, I had to think about that because you never need it. But there's a few weird things that you can do like that, and that's what final does. If you use final on a primitive, that means it's a constant. And its value can't change once you set it. Okay?
A non-derivative, it basically makes it not immutable.
If you use it on an object, it means you can't change what the pointer points to. That's not quite the same as immutable. Okay? But that, I'm not going to put that on a test. That's minutia. Okay. So polymorphism rules. The first one is the type, the declared type, declared determines what can be called without casting. So when we had our array of type staff member, and we want to determine whether polymorphism is going to work or not, the declared type of staff member, look in the staff member class, even though it's abstract, and whatever methods are defined in there, whether they're abstract or not, those are the ones that I can call automatically without casting. So in our case, the important one being the pay method. Even though it's abstract, it's declared there. It's listed in that class so the children can call it automatically. Okay? The actual object. So what did you use new with? Determines what will be called. So if I'm actually dealing with a volunteer, I'm not going to call employees pay method. I'm going to call volunteers pay method. Okay? So whenever I use, if I said new volunteer, it'll be volunteers method. If I use new hourly, it will be hourly's pay method, etc. Okay? So those are the two, that's the simple version. Generally speaking, that will appear in some context on your exam. Now, whether we're going to do the complex one next time, there's more to it than just this, unfortunately. And so that will bring us into some rules about designing classes. What should we do to avoid all the complex stuff? So that could also appear as a short answer question on an exam. But 95% of the time, this will suffice. If you find yourself in a bind, you want to think about whether your polymorphism is going to work or not, this is what you can go through. Okay? All right. So we added a visibility modifier when we start talking about inheritance. So we know about private and public. We talked about protected. Protected, again, I would say only make stuff protected when to avoid using protected makes things really, really confusing and difficult to read. Okay? In particular, I'm talking about instance variables. We don't want to make them public. Occasionally, we'll make stuff be protected because to not do so makes everything really convoluted. Okay? So what that means, remember what protected does, it means the child class can access, if I have a parent class that declares an instance variable to be protected, the child has access to it. Okay? The reason why we still want to try to avoid it is because I might have some classes that are part of a library and someone else is using my library and decides to extend some of my classes, and now they can start messing with my instance variables. Okay? So only in rare cases would I really want that to have happen. I want to make as frequently as possible anyone using my stuff to have to call methods to change anything. That way my stuff can control how it gets changed. That's the encapsulation stuff that I've mentioned a million times already. Okay? So still, watch out. So as far as instance variables go, never do this. Yes?
So, is there a case you can think of where, or type of case where you use protected versus public?
We will encounter them eventually, and then I'll point out why I selected that particular design technique at that point.
Okay.
So for now, the short answer is still make everything private. Okay? So public, pretty much never. There might be like 0.01% of the time where you have to do it. Protected, rarely. Okay? And private, you should always start out with. So, in fact, always start out with private. And every once in a while, so this happens probably more frequently than once in a while. Frequent, let's call it frequent. Okay? So whenever I decide to change, I realize that private is not doing the job that I want, I will go from private to default visibility. Okay? Here's the problem with default visibility. It's a legitimate modifier. But on your exam, this is, so when you're writing the solution to your exam, let's pretend like this is an exam. Public class, blah. I've got an integer, integer A, integer B, string, str. I've got all my instance variables here. I'm going to count off. Okay? I want to see private for each and every one of those. And unfortunately, in subsequent times that I've taught this class, is the same people keep not using private on their instance variables throughout the entire semester, and they lose those same points on every exam. Okay? So try to get into the habit. I know you're thinking local variables, you're confusing local variables, but you don't put a visibility modifier on at all. That's where the confusion is coming from. You're used to not doing it for local variables. But I want to see it for instance variables. And I don't want to see it for local variables. That's nonsense. Okay? So make sure that you put private on there. For all of them. Okay? However, sometimes, this will happen somewhat frequently in this class, I want to make those be the next level. I want to make them be default. I wish there was a keyword for it. Unfortunately, the keyword is no keyword. So if I take private back off of here and put nothing, I just made those be default visibility, which is not terrible. Okay? So, but I'm telling you now, so don't try to justify your leaving private off of there by saying, oh, I was using default visibility. Okay? No, I want to see private. Later, there might be a related question that says, what if you decided to make your integers be default visibility? What are the consequences? And you answer it. Okay? But I want to try to brainwash you to always use private first. And then only if you know what you're doing, increase the visibility. Here's why that I am okay with these two, although I will always start out with private. When you make something be default visibility, what you are doing is saying classes in the package can access those variables. Okay? We've been using a package statement, but I told you it just indicated the folder. Well, that's still what it is. The classes that you place in the same folder are considered to be closely related, and that's why they're said to be part of a package. Closely related classes, it makes sense in many cases to let them, for readability purposes and other simplifications, to let them access the data from each other. Okay? I'm still going to start out with private, but some of those variables could very well be changed to default visibility because I want to allow that access. Okay? Someone who's trying to extend one of my classes is not going to be able to use those variables unless I make them protected, which I don't want to do. Okay? So that's where there's 4 visibility levels. And in this order, they're increasingly visible to people who might want to misuse those variables.
The protected keyword, does it open it up to other classes in the package, or only other classes?
It will still be visible to other classes in the package. So yeah, it's backwards compatible. So if I make something protected, that implies it's also default. The problem is I can now extend, I've got some classes in a package, I extend them over here somewhere else, and now I can access the protected variables. That's what we want to avoid. But stuff in the same package, you're developing those classes together. So it's entirely possible that you've got some idea about interdependencies that they should have. But that's where it should end. Cut that off once you leave that package and you start working in some other package. Okay? We want to limit the sharing of information between different packages through the public methods. Okay? We don't want to let them access each other's variables, certainly. So just so you can't say, oh, I meant for those to be default. The answer is make them all private unless I specifically have some later portion of the question say, should you make that be default? Why? Something like that. Okay? So please don't be that person that loses points on every single exam because you made your variables not be private. Questions? All right. See you next time.
You know, if you were talking about people other than yourself using the board, I'm not